Vector packet processing, data plane development kit, user space networking. Now, this might not be concepts that a lot of people know. However, they are very important when it comes to our firewalls and the way that we implement next generation security. If you checked our website, you probably saw that our firewalls do more than nothing and simple firewall rules. They also do next generation security service with the IDS IPS engine, which is based on Suricata, and DNS security and content filtering. Traditionally, these have been processes that are very heavy from a CPU perspective. So you take a regular firewall and you start turning on all these advanced security features, and what you will see is a significant drop in performance that is not only seen on the throughput that's coming out of a site, but also the throughput of a VPN tunnel. And although I'm going to make a separate video to discuss the IPS functions and the content filtering, and another one to describe the way that we do VPNs, I wanted to focus on the three core concepts that I previously listed and get you to understand one of the big advantages of moving to a meter solution. So let's think about how a traditional operating system will process packets. In an overly simplified way, it will do it one by one, taking the packet, copying it into the kernel space. The operating system will have the user space where the usual applications live in, that's quite bounded, and then the kernel space where the CPU can pretty much do whatever it wants. And in this kernel space, it will then start applying all the rules that you set up in the dashboard and any sort of next generation filtering. And there are a few problems with this. First of all, although this system is very well known and has been for a lot of years, it still takes one packet at a time, which, as you can imagine, for a firewall that's dealing with a large traffic volume, it might become problematic. Secondly, because the CPU has to wear many hats and go from the user space into the kernel space, back and forward, that takes a strain on it, not only when it comes to it changing roles, but also because it has to always copy from the user space buffer into the kernel buffer and then back again. So this is where user space networking comes in, because it gives the processor the ability to deal with those packets in the user space. So not only it doesn't have to copy them from different parts of the memory and change roles from kernel into the user space, but it can also process packets as a bulk, let's say 32 or 64 packets, which is very much the equivalent of moving bricks one by one, let's say across a bridge, versus taking a forklift and take 64 of those bricks and then get them across. This is a overly simplified way of looking at this. There's a lot of very high, cool and advanced technology, but what it actually means for you as an end user is not only much faster processing, so we see 3 to 10x times increases, but also the fact that when you deploy one of these meter firewalls and you start turning on all these features, the degradation in performance is much less acute than with a regular firewall. And this is actually very important because in the last few years, because most of the firewalls on the market are operating in the kernel space, it forced a lot of people to look at third-party cloud services when it comes to these security features. And although you might have use cases where you would like to use such as SSE offering, let's say for SSL decrypt, if you just want regular protection and then direct internet access, you do not have to worry that by deploying our firewalls and turning on all these features that the actual end users will suffer, because especially at high peak times, the throughput will be so low and everybody will notice it.